Hey everybody, today in this video we are going to cover the Aurora and its lenses. Now, depending on what lenses you purchase, they're all going to have a particular focal distance. So the distance from where the lens mounts up here on the head to the material that you're trying to engrave on. So we have to figure out via a chart that is in the knowledge base what the distance is for each lens. Now this is programmable in the autofocus, but this video is going to specifically cover finding the perfect focus and tuning that in per each lens. We'll probably just do one lens, but the process is the same regardless. And once you get that measurement, it's going to be easy to fine-tune the autofocus if you want to input that. There's going to be a whole other article and video on using the autofocus and manipulating the software for the autofocus per lens. Okay, so looking at the lenses, we have different numbers on them. So we have our smallest lens and also most powerful. And then we have our larger lens, and keep in mind that when we switch out these lenses, we're getting a larger work area. All of the chart for all of this is listed in the knowledge base and also the manual. And we have the 290, which would be our largest lens for this machine. Now, it comes with a ring, and this ring should always stay attached up there. This is actually for my UV laser. I'm just taking it off because a lot of the times you will get this lens, but you will go to swap them out and this comes off with the other lens that's in there. And it's not going to look correct. You're going to be like, oh, they sent me the wrong lens. No, this ring needs to stay off of the laser or off of the lens and attached to the laser. And looking at the Galvo head, this is what it looks like from underneath. You have your ring where you are screwing in the lenses, and then this is where our mirrors are. We have two butterfly mirrors in there that are projecting onto the surface. So during this test, we're going to do a couple of different things. You are going to need some type of metal to test on, to fine tune. We are going to be moving the laser head, the Galvo head, up and down with our Z move buttons. So we're going to move it up and down to focus and try to find the sweet spot. We're going to want a tape measure or ruler or something to measure the distance so we can write that down and make sure that we continually use the same focal distance. I like to mark the lens size and also the focal distance on my lens cover, so that when I put it away and I change it out, I know exactly where I need to be. So that's what we're going to need. We're going to need a ruler or tape measure so that we can measure from the bed up to the bottom of our lens. All right, let me get one of these lenses on there, and we will start out by checking out how to do this first. It is fairly easy. We slide it up in there and we carefully thread it on. Now we are using the F160 first, so let's go over to the computer and see what there's variations of lenses, so there's usually a threshold, and I'll point that out when we get over the computer, but I want to know what the factory measurements should be, and we're going to start out with those. Okay, so on the computer, let's take a look at this real quick. The article that you're going to be looking for is how to calibrate focal distance on the Thunder Aurora. And this is for both version 1, first generation, and second generation Galvos. If we slide down to the data for the lenses, we're looking at the lens size, right here, and then the measurement in focal range. This is going to be from the T-slot table or your Allen threaded table. So what we're looking at is this number right here. So again, like I mentioned earlier, there's a threshold of where you'll find the perfect focus. of course, working in millimeters, if you have a way to measure in millimeters, that's going to have the most resolution. What I mean by that is the finest detail, because, you know, 0 to 8 or 8.6, there's not a lot of measurements in between. But if you go from, you know, 218 to 219 millimeters, there's a lot of numbers in between there where you can really fine-tune that adjustment. But most people are going to have some type of a ruler or tape measure that is in inches, so quick reference, easier to get it set up and then fine-tune from there. So we're going to work with the F160, and we need to be a starting point of at least 8.5 inches. So let's go back over to the machine and figure this one out. Okay, so one of the first things I'm going to do is I'm going to grab my piece of material. I have my tape measure there. I'm going to put this under the autofocus dot, and I'm going to autofocus this in, and it's tuned to whatever lens comes with the machine, so it should be pretty close to being perfect. I'm not saying that there are some variables, and you could probably fine-tune it even better, but I'm going to let the autofocus do its thing. All right, that's autofocused. I'm just going to create a graphic real quick. I'm actually going to use the state of Texas. We're going to fill it, and we're going to fill it at a rate that is not a lot of power and is kind of slow, so that we can adjust this the height of the Z and find out the perfect distance that we need to set this to. So let's do that. Let me turn the light off here real quick just so you can see. I do have my little outline of Texas, and I'm going to hit the start button or the play button down here. Let me move this a little bit. All right, I'm going to hit the play button, and it's going to start doing its magic. Now, this is where we're going to fine tune. Now, that looks like a really good beam, really strong. No matter which way you go, whether you go down or up, it's going to fade away. But we're trying to find the perfect spot. So you saw it got a little bit brighter and then it went away. So if we bump the focus up by pressing the button little by little, we lost it again. So as you can tell, let me zoom in here a little bit. As I move up and down, it gets a little bit brighter, and you can audibly and visually tell the difference. We're just looking for the most intense beam. Do wear your PPE glasses if you need to, or look at this through the door, the green glass on the door. I'm obviously using this as a demonstration only, so follow the proper guidelines to be safe with your eyes. All right, so if I move up a little bit, it goes away. Move down, and I'm going to put my microphone next to it because you can hear it. All right, I think right there is the height that I need to be at to be perfect. So let's measure that. All right, so looking at our design that we just did in the state of Texas here, we can see the variations that we had while we were messing with the focus and how it impacts how it engraves. So once we had it finally tuned in, we can see that we got a pretty nice, close to black. That's a dark brown, almost black. A little bit of setting manipulation and we'll get black out of that one. But you can see how that made a difference, and how adjusting it slightly, if you can see there's a slight variation on the bottom where we started at the focus point and where it got a little bit different up top. So you can use your focus to get different results as well. You're basically defocusing the beam, making it a little bit softer, diffusing it a little bit when you adjust up or down. But for the most part, we want the smallest, strongest dot possible. So what I'm going to do now is I'm going to pull back out on this one. What I'm going to do now is I'm going to measure the distance from my bed to the bottom of my lens. Now, the setting or the parameters that are listed, on the documents page usually go to about the middle of the lens. For ease, I'm going to go to the bottom of the lens, just because if I want to build some type of focal stick, I can make it so that it runs into the bottom of this lens piece, so I can measure perfectly the distance. So this was, let's put our piece of material back because that's where we were engraving. This is 7.5 inches. This is almost, I'm glad it came to that fraction, because I can easily calculate 7.5 if we're working in millimeters, or entering it into the AutoFocus software. Then we can do a conversion real quick of that 7.5. But that's how we're going to get our measurement. That's how you would cut out a jig or make some type of focal stick, or, you know, like I said, edit the software so that you know the exact distance you need to be in focus perfectly on your material. All right, and just to wrap things up on this video, I did engrave on here the focal distance, or the focal lens, which is an f160. The focal distance is 7.5 to the bottom. I measured it to the bottom, which it works out to be 190.5 millimeters. So again, 7.5 inches from the bottom of the lens. So if I created a focal stick, I would probably put a little L here so that I can put it right up against here and go 7.5 inches to whatever surface I'm engraving on. So whether it was like that, I would go from here 7.5 inches to the bottom of my lens. And that's kind of how I do it. Again, I like to try to label this. There's a whole bunch of tests on the UV laser, but this is perfect for me to open it up and say, all right, my F160 is 7.5 or 7.5 inches, or 190.5 millimeters from the surface of my material to the bottom of the lens. Hope that helped.